Hey everyone, welcome. We're here today to dive into the fascinating world of thermodynamics. It's a subject that might sound complex, but it's really about understanding the fundamental concepts of energy.
That's right, Taylor. Thermodynamics is the bedrock of so many scientific and engineering disciplines. It's a study of how energy, particularly heat, relates to work and the property of matters.
Think about it. Everything from the car you drive to the food you eat involves thermodynamic processes. We're going to break down the core concepts to make it clear and accessible.
So let's start with a clear definition. Thermodynamics is a branch of physics that explores the relationship between heat, work, and energy. It's not just about heat, but the entire spectrum of energy transformation.
Exactly. It's about how energy flows and changes within a system and how this system reacts with its environment. For example, consider a power plant. It takes the chemical energy in fuel, converts it to heat, and then this heat is transformed into electrical energy. Therefore, thermodynamics provides the tools to analyze the efficiency of each step.
And it's important to remember that thermodynamics is a macroscopic science. We're dealing with the bulk property, not the individual and molecule, which falls under microscopic science.
To analyze these energy transformations, we need to find some key terms. First, we have the system, which is the specific part of the universe we're focusing on.
Right. The system could be anything: a piston engine assembly an engine, a refrigerator, or even the Earth's atmosphere. Then we have the surrounding, which is everything outside the system that can interact with it.
And the boundary is the surface that separates the system from its surroundings. It can be real or imaginary. It can be fixed or movable. A closed system is one that will have heat transfer, but no mass transfer. An open system has both mass and heat transfer. As for an isolated system, it has neither.
For example, a sealed thermos containing hot coffee is a closed system. It allows heat transfer, but not the transfer of coffee itself.
Let's touch on the fundamental laws that govern thermodynamics. The first law, as we mentioned, is the law of conservation of energy. It states that energy is neither created nor destroyed, only transformed. As seen in the diagram here, the potential energy is at its maximum here and there is no kinetic energy. However, once you get to this point, all the potential energy is transformed into kinetic energy. Once again, once you go to this point, all the kinetic energy is transformed into potential energy, which is a constant system here, therefore, which leads to the conclusion that energy is conserved.
Yes, and this law leads to the concept of internal energy, which is the total energy contained within a system. The change in internal energy equals to the heat added minus the work done by the system.
The second law is about entropy, which is a measure of disorder or randomness of a given system. It states that the total entropy of an isolated system can only increase over time or remain constant in ideal cases.
This law explains why heat flows from hot to cold and why processes are generally non-reversible. It also sets limit on the efficiency of energy conversion.
The applications of thermodynamics are vast and diverse. In engineering, it's crucial for designing engines, power plants, and refrigeration systems.
Absolutely. In chemistry, it helps predict the spontaneity and equilibrium reaction. In material science, it is used to understand phase transition and material properties.
Think about a simple example: boiling water. The heat is added to the water, which will increase its internal energy, causing it to change phases from a liquid to a vapor. Thermodynamics helps us to calculate the amount of heat required and the work done during this process.
Or consider a car engine. The combustion of fuel releases heat, which is converted to mechanical work to move the car. Thermodynamics helps us analyze the efficiency of this conversation.
What I think you meant to say, Praveen, is conversion, not conversation.
Yes, sorry. Conversion and optimize the engine's performance.
So, in essence, thermodynamics is the science of energy and how it transforms. It's a powerful framework for understanding and predicting how energy behaves in various systems.
We've just scratched the surface here. There's so much more to explore in the world of thermodynamics, but we hope this has given you a solid foundation.
Thanks for joining us. We encourage you to delve deeper into this fascinating subject.
And if only love was easy to understand as thermodynamics is.
Praveen, here we go again.